Since the dawn of time, humanity has looked up at the stars, wondering what truly governs the dance of the cosmos. And now, one of you asked a question that cuts right to the core of that mystery. If 3I Atlas entered our solar system, why isn't it being pulled in by the sun's gravity? Tonight, we dive into that enigma to uncover whether the most powerful force in our cosmic neighborhood might not have full control after all. The sun, a star with a gravitational force so powerful that it has held entire planets captive for billions of years. And yet, it cannot capture 3I Atlas, an interstellar comet that came from another star system, crossed stars, and is simply passing straight through. How is it possible that the most powerful celestial body in the solar system cannot hold on to such a small object? And the most intriguing part, not even the world's most advanced telescopes, like James Webb, can see it clearly. The comet that the sun cannot hold and James Webb cannot clearly see. Today, we will find out why 3I Atlas defies the laws of gravity and the limits of our technology. And the more we understand about it, the more questions arise. Point 3I Atlas is the third interstellar visitor ever detected crossing our solar system. Before it, we had the mysterious Oumuamua in 2017, the one that looked more like an artifact than a comet. And Borisov in 2019, a more traditional comet, but also coming from another system. Now, 3I Atlas follows the same pattern. It comes from outside, crosses solar space, and leaves. The difference is the absurd speed at which it travels, about 60 kilometers per second. This means that the sun, even with its colossal force, doesn't have time to act. By the time the comet approaches, it is already on its way out. That's where the mystery begins. Why the sun cannot capture it? The sun's gravity is immense, but it is not infinite. When something approaches, the sun's force tries to pull it in, but this only works if the object loses some of its kinetic energy. 3I Atlas comes from so far away and so fast that its kinetic energy surpasses the solar gravitational pull. It does not orbit the sun like the planets. It follows a hyperbolic trajectory. That is, it comes, cuts across the solar system, and leaves forever. For the sun to capture it, something would have to interfere with its path. Perhaps a planet, a dust cloud, a collision. But space is vast and the time is too short. The result is simple. The sun deflects it, but does not dominate it. It's like trying to stop a meteor with a magnet. The force is great, but not in the right direction. But imagine, what if one day the sun did manage to trap a visitor like this? It would be the birth of a new orbit, a new body coming from another system, perhaps even something that doesn't exist anywhere else in the universe. Why telescopes can't see it clearly? Now comes another question that many people ask. How can the James Webb, capable of seeing galaxies billions of light years away, not clearly show 3I Atlas, which is right here in our cosmic backyard? The answer lies in the telescope's purpose. James Webb was designed to observe distant, static, and extremely faint objects like nebulas and ancient stars. 3I Atlas, on the other hand, is the opposite of that. A small, bright body in constant motion. It moves so fast that during the camera's exposure time, it leaves the field of view. The result is a blurred, confused image, as if the telescope were trying to photograph a moving lightning bolt. And even when focus is achieved, what is mostly seen is the brightness of the coma, the cloud of dust and gas surrounding the nucleus, and not the solid nucleus itself. It's like trying to see a flashlight inside a fog. The light is there, but the details are lost. Despite these limitations, scientists worldwide are gathering precious information about 3I Atlas. The Hubble telescope calculated that its nucleus is between 440 meters and 5.6 kilometers in diameter, much smaller than expected. James Webb detected high emissions of carbon dioxide and carbon monoxide, suggesting an exotic chemical composition different from most ordinary comets. And ground-based telescopes like Gemini confirmed something even more curious. 3I Atlas releases cyanide, CN, but produces almost no complex carbon compounds. This places it among the carbon chain depleted comets, a rare and mysterious characteristic. Furthermore, polarimetric measurements revealed something never before seen, a deep and narrow negative polarization, indicating that the dust composing it is unique, perhaps formed under conditions that never existed here. All of this suggests that 3I Atlas may come from a star system vastly different from ours, with completely distinct chemistry, temperature, and history. It is literally a fragment of another sun. But now what? What can we expect from 3I Atlas? It is approaching perihelion, the point closest to the sun, and the chances are that it will become even more active. Some scientists believe it may fragment, releasing large amounts of gas and dust, revealing the pure material of its interior. Others think it will simply keep going, returning to the interstellar cold from where it came. But there is something everyone agrees on. Every new observation brings more questions than answers. And that's what makes 3I Atlas so fascinating. It is a reminder that the universe is full of visitors, and some pass by so quickly that we barely have time to say hello. 3I Atlas challenges the sun, escapes telescopes, and intrigues scientists. But perhaps the greatest mystery is not in it, but in us. Why do we feel such a fascination for what comes from outside? Perhaps because on some level, 3I Atlas reminds us that we too are travelers. Circling a star, crossing space in search of answers. The universe is full of secrets, and every visitor like this is a reminder that we still know very little about the place we call out there. I'm new Michio Kaku, and this was another deep dive into the unknown. See you at the next mystery of the cosmos here on Beyond Parallax.